Hey, hello, how are you? Good morning for those who are in my same time zone. Many of you probably are on the opposite side, so good night to you. Thanks for being so late here with me. And well, for the rest, just have a great day. I see many comments, and that puts me so happy. I really enjoy see you commenting, talking here on chat. So let's take a moment to say hi to Isra, say hello to Fashik, hiya to Butcher. Here we go, say Samu. So I think you're excited. Sorry, Sam Munda. Isra says hey. So BK24 says hello. Hey, wow, everyone. For Spark is your good student. I need Java with my JavaScript. So you're a Java developer? Um, is that correct? Or you just joking about what we were talking yesterday? Well, last session. Hi, says here again. Hopeful says hello. Great, Uvu. Isra. And yeah, some coffee. I don't know if you spy me taking a sip. Sorry, I was waiting until this was finished dripping. I was preparing myself. This is origami method. I really like coffee. I enjoy having great coffee at home. Um, I don't know how to translate, but I think that's specialty coffee too. So great for the morning. Smith says hi. So, again, hello. I'm really glad to have you all here. And thanks. I hope you could see yesterday's session. Well, again, it's yesterday for me, but I don't know for you. Well, part one of the universe of JavaScript. If you didn't, don't worry. You can always watch the recording on YouTube or Twitch, but stay here for now. And after that, I recommend you to, well, not after that, but at some point, yeah, I recommend you to watch the recording. What did we see yesterday? Well, yesterday we were talking about, again, sorry, yesterday, in part one. What was covered, yeah, no worries. Um, and part one, we were talking about JavaScript language. We were talking about some of the differences between other languages, what the history of the language has been, how this is interpretation of the ECMAScript, which is the standard that gives JavaScript the body for being a language, for saying that way. We were talking about, for example, the difference between TypeScript and how TypeScript indeed it's the same interpretation, but adding the types. We were talking about why it's called JavaScript, which is that Spark circuits make sense in this comment because they call it JavaScript for the Java language, and doesn't make sense, and I don't like it. Besides, I love the language, I don't like the name. Well, what else? We were talking about the primitive values here on JavaScript, and to do a little recap, remember that the primitive values are the ones that are immutable in our code. So we talk about making a mental model too for not for JavaScript but for helping programming. Having a mental model that tells you what happened in your code without having to run it, it's the best practice. And these mental models should change depending on the language because there are different things happening in JavaScript than in Java, for example, or in C, or in Python, or in C Sharp, even, or in C, and etc. It depends on the language. And here on JavaScript, the mental model I wanted us to create it's the one of the universe. And this is not only by me, and this is not an Alberto invention, but a great author called Dan Abramwood that has a series of, well, that has a course, but also a series of posts and etc. that explain this, having the mental model of the universe in which your code is this little planet and all things in there in the universe that you can stare using, for example, a telescope, are part of already of the JavaScript universe. And these primitive values are, for example, the number, the strings, the symbol that I always forgot, the booleans, the undefined, the null, and well, big ints, which is a special type of number, right? Um, what else? What else we checked yesterday? I think that's all. But we spent some time creating this mental model. I think that's one of the most important parts. We explained these primitive values in depth. So again, if you miss it, you can check it. But if you are here right now, don't worry, you will understand because I will try to explain everything again and again. That helps for you to absorb that all knowledge, right? So let me start sharing my screen. Uh-huh. So here we are. And this is where we leave it yesterday, right? With the JavaScript page, the Node page, and we were playing here on console. We are going to open an editor and start creating YAYA's files, YAYA scripts, to make this, how to say it, to make this like in a more interactive way. But again, if you don't have Node installed, don't worry. You can always open your um, how to say it, your inspector, your console from the browser, and you can write JavaScript here. The problem is that for writing big amounts of lines of code, well, you will have to do like shift enter or things like that, and well, that it's trolling. Another thing you can do, it's you can open here on the browser and look for carbon pen. No, yeah, I think it was carbon fiber pen. Oh yeah, I don't remember the name, but you can write JavaScript editor. And here's, for example, it's playground, JS Fiddle. I remember there was one called Carver Pen or something like that. Let me Code Pen. I was mixing two different tools. One called Carbon, which I use for taking. Uh, oh, sorry. Oh, oh, you got me sneezing. Sorry. The one I use for you're seeing my screen, right? Yeah, you're seeing my screen. The one I use for taking snapshots of code, which is Carbon, and the other one that I use here it's CodePen. This is a great tool, and it allows you to use JavaScript here also on the web. So let me share this with you. Bless you. Thank you. Give me a second. I need to sneeze again. I'll be back in a second. I love the video feedback fractal. Yeah, I know. Sorry, I usually use two monitors, but currently the one's not available, so that's why I'm sharing here this. Sorry about that. Yeah, again, CodePen for you to use to follow me along. You need an account, and you can. I think you don't need an account. Yeah, you can start just coding. You can hide this HTML and CSS thing, and just start coding here. Like let a equal 10 console.log the value of a is a. And where I run this, I always forgot. I think command enter for my JavaScript. Yes, console. Okay, yeah. If I hit enter, no, command enter. I don't know what moment this runs, but well, here's the console. And so that's for you. Yeah, I don't want to use it right now. And what's next? Hmm. Is there somewhere we are able to access the past session from this global highway? In yeah, yeah, again in Twitch, so you can just try write http/mlh.tv, and here's that's the MLH page. If I change, well, I don't know what happened if I change desktops here. Are you able to see my? Are you seeing currently Discord, or you're still seeing the stream? That's a great question. I don't know what happened there. Okay, but yeah, the you can watch the past session in Dutch. Uh, let's resume. We were talking about what we're going to do right now, right? So we checked what JavaScript is, what this node thing is. We should have node installed for following me in your current text editor. If you don't have node installed yet, you can install it. You going here to nodejs.org. In Node.js, you can download the LTS version. I recommend you to download the LTS one because well, it's more stable. Actually, that's the main reason. But again, if you don't, you can use CodePen. I shared the link with you. If you don't want to use CodePen, you can just well, click here and inspect every window from your um, browser. And here, just look for the well, this is too big. To the console here, and I'm going to make this less bigger since we are moving to the text editor right now. Um, and let's take a look to what we're still missing from the 33 concepts we should all know, right? Sorry about the noise. That was a big truck. Um, Call stack, primitive values, values types, reference types, implicit, explicit, numeral struct. We check this function, block, scope. Well, this is something I need to explain. But before we get to this, the function scope and the block scope and lexical scope, we need to understand what function is, right? So yesterday, talking about this JavaScript universe, we mentioned that everything it's an object, right? Well, I want to clarify that everything it's an object except for the primitive values. And now let's open this editor to explain that. Let me start, remove this from sharing and open my editor. And let me create a folder for this. Oh, thanks for sharing on the YouTube channel and also here. Mhm. Got here. Global hackney. Okay, here it is. So let me start sharing that. I just created this empty folder called JS Universe. And well, let's open a new file called index.js. Create this file. Here we are going to talk, and let me make this bigger. It's that big enough, or you want me to do it much bigger? There was a thing to pointer. I don't remember. Well, I used to have one thing to go out attach to go comment latex material spell terminal activate fold import line limiting circle. Wow. I hope you can see this well. Plenty big for me. Okay, thank you. We are going to talk about first a recap in JS, well, JavaScript, objects, and functions. Then we are going to talk about sentences. No, how to say it? What's the name of this? I always forgot. Um, assignment. Assignment. No, well, don't worry. Let's start with this. And the other one I was thinking of, it's control flow, and I had other one, the program structure. Yeah, I forgot. This was expressions and statements. Yes, then control flow. Then we called about loops, and well, Let's just start with this. Mm. First type of value are number. This is 8 equal 10. The second type of value, it's 2 equals string, a hello. Third type of value equal boolean, say true. Then undefined, thank you, Copilot. This is very helpful. Let null. Then symbol. This is very interesting, and I want you to take a look at this console.log about just f. Big int. This is let g, for example, this number. Then that's it. 1, 2, 3, 4, 5, 7. I think those are all. Mhm. Just let me confirm. 1, 2, 3, 5, 7. Right. 1, 2, 3. Yeah. Yeah. These are the primitive numbers, right? Um, Let me open a console, and here we can just say node index.js, and the symbol is full, right? But what does that mean? Because if we say, for example, at this point, console.log all of this, what we get, 10, well, let's give it a little space. And now 10, the number, hello, the string, true, the boolean, undefined, the undefined, null, the null, and symbol, the symbol, right? But I forgot yesterday, well, not forgot, but I didn't mention that there's a way we can inspect these types in JavaScript called type of. Type of A, type of B, type of C, type of D, type of E, and type of F. So let's run this again to see that. 10, it's a number. Hello, it's a string. True, it's a boolean. Undefined, it's an undefined. No, it's an object. This is tricky. And symbol, it's a symbol. Actually, um, all of these primitive values, and I want to run this again just to verify something. Yeah, all of these primitive values are unmutable. That, remember from yesterday's session, means that I cannot say 10, for example, it's equal to 11. That this is not possible. Or I cannot say something it's equal to something else. Yeah, exactly. This is an error, and we will see that. Invalid left-hand sign assignment. I cannot say this happens. These are immutable. And to complement this with a more graphical way, let me prepare for you in a second a Figma session to try to make this new design file. And then, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, Okay, let me present again. What? Yeah, hello. So this is our planet, right? This planet means this is our code. And this has a complete universe around it. It's not filled, but it has a stroke of 10. Right? So this involving all JavaScript universe. For those who are familiar with theory of how to say it, groups, this will be easier. Universe. This is the complete universe. This is our code, living not in the middle, but well, at some point of the universe. And outside, out there, there are, for example, a true, which is a boolean, right? And outside there is another thing that's, for example, a 10 as number. But again, for example, it can be a 10 that's inside a string, right? And same as this, we can find another that is, for example, the something um, string that I was mentioning. So what happened when in our code we have this little part, this little variable called, for simpler reasons, I'm going to call it A, right? Remember, A. And we assign it to be 10. So we point with this little row to the 10 value, right? So A has the value of 10, but that doesn't mean A is 10. No, no, no. A contains or points or has the value of 10. That's the mental model we were talking yesterday, this one. And with something, if we resign in another line of code saying, well, um, let's write it here. So let A equal 10, right? And what happens when we say A equal something? Well, in that moment, this line becomes pointing this other thing. So we reassign the value. The pointer changes, right? And yesterday, we were given an example of saying now, hey, it's an array that contains, for example, 10, and then contains something, and then contains whatever value we declare here. True. So in this moment, A become an object. And now A points here, here, and here. But now that A is an object, I want you to understand that this changes a lot. Because if previously we'd say something like let b equals a, doesn't matter if we change after this a something, let, sorry, b still being 10 at this point. And in this point, b still being 10. I want you to guess what happened here after a it's an object. Let's take a look at that in code. First, let's comment this and this, and add a label that this is not possible since primitive values are immutable. This is not possible since primitive values are immutable. Nice. And let's start with another that's let object equal object. Objects here can be declared as these curly brackets, and objects has two main possibles. An object can have a property. In this case, in JavaScript, they are separated with a key and a value. The key here is name, and its value is John. So, for example, we can say console log the object completely, and the type of the object, and console log the object.name and the type of that object name, because this property has a type and this other property has another type, the age, right? So let's run this to explore that, and let's comment the rest of this because we don't want it anymore. So we have the object, full object contained by the curly brackets. This is type object, but it contains a property name. This name value is John, and it type it's string. The age is 30, and it type it's number, right? This far we're good. Check how we accessing it. There are two main ways we can access an object property: with the dot or with indicating this way the with the curly bracket the literal property key. So we will see the output is the same. So we can access via dot or via square brackets inside a string indicating the property. But this far, the object just have properties. Objects can have methods. And for example, this object can have a method to change name, or to, let's say, to greet. And here inside we declare a function. When a function is inside an object, it is called a method. But what a function is? Well, a function can be declared two ways in JavaScript. With the function statement, we can add a name. Let's say this is a hello world regular function. It doesn't take parameters for make this simpler, but I want you to know that parameters goes here inside these simpler brackets. And a function, well, let's give a parameter, right? Parameter. The parameter will be a name to greet, and we can say hello world name to greet, and we can return the greeting, right? This is a way we can declare a function, and a way we can call the function. Well, JavaScript is giving me the second way to declare a function, and I'm going to take advantage of that. Is this? This is a regular function, the old way you can think of it, and this is an arrow function. They are called arrow functions because of this. Actually, I use font that has some special things. That, for example, if I add two uh, equal, they look just like one. If I add three, they're just like the three equality. For example, if I add this and an equal, it's the difference. Okay, but this is for the font. Yeah, don't worry. How you say this arrow, there is not a special character. It's just an equal symbol and the bigger 10 and this other symbol. These two together for me looks like an arrow, right? So that's all. That's why they are called arrow functions. Give me a second. I need to sneeze again. Sorry, I'm back. Okay. And you may be wondering, this is a hello regular function and this is a hello arrow function. What's the difference between these two? Well, remember the hoisting thing? Well, const variables, same as let variables, do not make hoisting. So let's quickly open another file that can be called hoisting.js, and let's explore this um, file to explain hoisting in JavaScript. Function declaration. This function can just say hello world, and function expression will say arrow function. Let's call arrow function. And well, before the way we can call these functions are here. Hello world regular function. And for example, since these two have the console log inside, but also return the message, we can comment the console log inside and execute the, for example, function instead with a parameter and pass it to the console log. Same with the other one. What's happening here, it's the return statement give us the message. So actually, we can store the output of the function in a variable. Let's do that. Let return message 1, and this is the hello world function passing to John, and then the return message 2, and this is the hello world arrow function, and let's change it to Alberto to make this different. And remember, we are storing the output here and here. So we can just console log the return message to. And let's do something else that's the type of, not the return message, but the hello world function. Now this is the arrow. This is the hello world regular function. And the type of the arrow function. Let's run this other one. We have hello Alberto and, well, hello John and hello Alberto. And the type of these, it's a function. So that's what I was mentioning, that all things in JavaScript are either objects, functions, or primitive values. We saw here that these types are number, string, boolean, undefined, etc. But we have symbol, object, and now the final one we didn't see yesterday. There are functions. Now we can go to the hoisting thing. Down now that we know how to call these functions, let's call them. So say hello. Say hello. We are going to call these. The way we called or execute these functions are with these square brackets after the word. And if they have parameters, we say the parameters here, right? So then say hi. One says hello and the other one says hi. Hi. Then let's add arrow function. Hello function, regular function. And let's execute this hoisting thing. And no problems yet, right? But what happens if we take these lines of code and we put them at the very beginning? Will these run without problem? Well, this is a problem. But check the problem. Reference error cannot access say hi before initialization. But say hi, it's the second one. Why that didn't happen with say hello? It's say hello are going to happen. Let's comment say hi and let's just run it saying the hello thing. Say hello doesn't have any problem, even that it's called before initialization. So remember the interpreted language here. What's happening? JavaScript engine comes and read first line. First line, it's a comment, so no problem. Second line, it's an empty line, so no problem. Third line, it says hello. What happened inside? Well, hoisting works this way. Even that it's an interpreted language, even that runs just in time, line by line, before all, there's like a quick view of the file. And in this quick view, it takes things like the function declaration, like var declaration, and put it on the very top and store it in memory. So according to JavaScript memory, it is a function called say hello. So what happened here? This function say hello exists in JavaScript memory even before it starts running. Not the same thing happened with the variable let. And since this is a narrow function, yeah, it is a function, but it is stored in a variable let. Let and const doesn't make hoisting. So what happened if we change this to var? Then can this happen? Let's take a look. Say hi is not a function. Something break. What happened if we take this and put it uh, after this was declared? Well, it's happening. So It doesn't matter if we say this, save this to bar or to anything else. Arrow functions doesn't perform hoisting. So again, that doesn't mean arrow functions are better, regular functions are better, or one before other. That doesn't mean anything. It's just how the language works. Understanding this and having it our mental model give us the advantage of preventing bugs, preventing errors, and even not just preventing these errors or having errors at all. But one thing, it's the difference between the errors that the program consider errors and the errors that us as developers consider errors, because this probably be something that we want to happen. This probably is something that we indeed want to perform, a call to the function even before it was declared. But sometimes, I don't know, for any reason, we can call these with different names. So in that order, with sorry, with similar names. So in that order, this will be an error because we're calling a function uh, that we don't want. Or if we reassign this, for example, let's say hi, it's not just this function, but another, and we call say hi here, but then another one time here. So we have the arrow function one and the arrow function two, but we cannot reassign to previous function declarations here. We cannot say hello here with another function. This will be a problem. Oh well, regular function two. Uh, you know, and even if we add it before, you know, so if we call it one way before declaration and then after declaration and then after redeclaration, it works, then it works with the two, it works the arrow function, and then after redeclaration it works too. The thing here again, it's not an error of the language, it's how we want it to work, because we know how this hoisting thing works in JavaScript, for example. And just to end these examples, let's do it with variables. Bar a equal 10, let b equal 20, and const c equal 30. And let's console log this here and this here. And let's see what happened. Well, again, we have a reference error cannot access b before initialization. But what happened? What happened with a? Why not a has the same error? Well, let's comment b and c and run it again. And this is very interesting. We mentioned that when the hoisting happened to the functions, the whole function here says hello regular function, right? Even before initialization. But the idea of it, the content of it, still happened. Not the same thing happened with variables. And that's why, not even if we call this to be bar r, it works, because storing this function in a variable will allow us to know that say hi exists. That's why the message changed. Let me look for it. Cannot access say hi before initialization. Then we change say hi to variable, and the problem was say hi is not a function. Okay, now we know say hi is something. It exists in the JavaScript memory, but that's not a function because say hi in this point was an undefined. An undefined, it's not a function. You know, when hoisting happens to variables, the variable exists in memory, but it has not been assigned to a value because value assignations happens in the moment. So at this point, the JavaScript engine tells us what happened to A. What's A? Well, thanks to hoisting, JavaScript memory knows that A exists, but it doesn't know what A it's containing yet because A it's not containing anything. The assignment of the value happens before this. So then variable A has 10, the value is assigned. Let B knows now that a variable it's called B and it's inside memory. Then const C, again, this tells JavaScript a variable exists that it's called C, and both are declared and assigned. We can do this in different steps. We can say B here, for example. So one thing it's declaring the variable, and another thing it's assigning the variable. Check that for C, that's a problem because as this happens, const declarations must be initialized. Remember, const can't change value, and when a const is declared, the initial value JavaScript gives it's undefined. So if we console log this, well, if we console log this, it will be undefined. The problem is to prevent errors, JavaScript requires us to assign its value when declaration, right? So that's why here now we can have 10, 20, and 30. And before this, A give us undefined. We know that exists, but we don't know what value contains. That's why B and C here have problems because JavaScript doesn't even know that they exist. And well, that's hoisting. Any questions this far? Give me a second now. Yeah, I'm back. Sorry. Still not used to that new arrow function syntax. I first learned JavaScript in the 19s. Slow. Okay, don't worry. JavaScript, it's really changing over time, and most of these things are syntactic sugar. I mean, like, doesn't change in practicity. For example, a lot of what React does, it's syntactic sugar, but in this case, there's a big difference. And I just show you, like, the way how JavaScript internally interprets an arrow function and a previous function, the regular functions, uh, are very differently. And you saw it. If you declare an arrow function with a let, and if you declare it with a bar, there are big difference. If you do a declaration of a function in a arrow function or in a regular function, the way how it behaves to the hosting changes a lot. Give me a second. changes a lot. So that's why I really, really encourage you to. The thing here is that's not just syntax, right? It's a different behavior. It's a different function indeed. The variables, the let, the cons are not just syntax, but there are really different ways to declare how JavaScript use this memory. So yeah, I know can be tricky, and for those who are relearning JavaScript because they all learned first at the 19s, it can be difficult. But that's the part of the intention here of having a mental model of JavaScript. Um, so we are done with functions. We can return them to the objects. So we mentioned that objects at this point can have these properties, but also a property that is a function. And these property that are functions are called classes. So we can say object.greeting and execute it, right? So what will happen? Let me comment the rest of these things. Yep, we don't have anything else. Node index. And we have the hello, right? Because the hello, I'm, well, and this is an interesting suggestion. Why this? What's this? Okay, I'm name and I am this again. What's this? Age. Well, let's run it. And we can see, hello, I'm John and I am 30 years old. But why we need to add the this dot name? Why not name just works? Name it's not defined. But what happens if we add something, a variable called let name equal Alberto, and we run this again? Hello, I'm Alberto and I'm 30 years old. The problem is that this might not be what we expected because this is a person, right? And let's change object here in all of this to person. And it is different a person that it's called John and another person that it's called Alberto, isn't it? Well, what this tells us is the immediate context of the value, sorry, of the variable. If we say this dot name, we are telling to the function that this is the immediate context object that contains it. So this is the person object. But let's return a little second to the web browser. So here on the web browser, we are going to return to our console here, and we are going to say this. What's this here? This, in the context of the browser, it's the windows. So here the window tell us that we have, for example, the React DevTools, the auto content, some things called the StarNet, the Webpack. But here you saw we have my JavaScript variable. So here, thanks to the context of the this, we can say this dot my JavaScript variable, and this is my JavaScript variable in the same value. So why this is important? Let's return to the code. Here, well, in this case, let's console.log this outside everything, outside the object, outside all, at the very first layer of our code. But also, let's do who am I? Oh, who am I? It will be a method of the person, and this will call console log dot this. What's this? And let's call this I'm I am dot blah, right? And let's make this person who am I? After just the that, we are going to call console log this. Let's run this. Well, I'm an empty object. And these outside all are also an empty object. Then what is happening? Why here, when I say this dot name, it gives us the person. Does that affect that here I'm calling an arrow function and and a regular function in the other one? Let's discover it. Here, the I'm has, sorry about that noise. Here, I'm has the complete object. And here, in the other call, it was an empty object. So, remember what I told you about having differences on functions and arrow functions? Well, another big difference is that the arrow function doesn't contain the this context. And that is a game changer, because where you are declaring these objects for example, what it's called programming, the object oriented programming paradigm, well, that changes a lot. If you declare a method that it's a getter or a setter, or you want to access the context of your object, and you want it to be a function that scales the scope, or that doesn't have access to the content of that, a private method that's called, well, heavy stuff. Not that heavy, but tricky stuff. Well, in this case, these contexts tell us that all information about the person, even the same function I'm referring to, right? Name, age, a greeting, and who am I? And it tells us, for example, for name, the value, for age, the value, but for greeting, it doesn't tell us the value. It tells us that it's a function that's called reading. It tells who am I, a function that it's called who am I. And you may be wondering why saying reading it's a function called reading, because we can change it. This is a non-name function, and we can do the same here. Actually, we can call just a function without name and without params, and call it console log, and this is an anonymous function. An identifier were expected, but we are not going to give it, and we are going to call it. This is grabbing a function and executing it, because how else we are going to call a function that has no name? Let's run this again. An anonymous function was called this way. So this function has no name. It's an anonymous one, but we are executing it at the moment, just after declaring it, right? Um, Execution. Well, same happens here. This is an anonymous function that receives the name of the property containing it, but we can call it with a name proper name of this function. So let's call this again. And now it changes, right? Because the greeting key containing the object John, you see, has a function that's called proper name of this function. This is the proper name of the function because now we give it a name. After that, same as this, being an anonymous function, just receives the name of this key. But what else can we say? What else? For example, why this still an empty string, an empty object? The whole context of JavaScript in this case doesn't have a context. It's just a file. Remember the console at the very first layer, the one containing all was the window. When you do, for example, Angular, components are class components. In React, they used to be like that, but now they change. Well, not now. I'm old, I think, around version 14, 15. I don't remember well. They changed the class components to be functional components. So they changed the paradigm there. Um, to be from classes to functions, and well, it changed a lot. You now have the hooks with the hooks was created to prevent people to use classes, because most people didn't know how to use classes. Most people didn't know how to do um, object-oriented programming. And well, again, that doesn't mean that it was bad at first. It means that most people, most programmers didn't know how to use it, and it found it difficult. And to prevent that and to force the language to be better, between quotes, they invented these hooks, which are just triggers to the life method cycles that already existed. And I see it with Angular. In Angular, they still have to be classes, they have life cycle methods, and there are properties of the class, the component class. That's the very use of this when you are using object-oriented programming. But let's do another thing, that it's I want person to be replicated, right? So let's call this person2 equal person. What will happen here then if I say the same things here? I'm going to delete this and I'm going to, well, I can leave that. Person 2. DG2, person 2. Let's call this, and the output is the same, right? The first, let me add a separator. Uh, Console.log and this separator. Okay, the first person it's John, age 30, with the greeting, who am I, blah blah blah. And I'm going to comment the call of the who am I. Well, actually, I'm going to delete it because it's duplicating things. So yeah, the complete object, type object, John, type string, 30, type number. Hello, I'm John, I am 30 years old. Same here, it's like a copy of it, right? So what happened if say at this point, person 2 equal person, but person 2 dot name will be Albert. What do you think will be the output? I'm just changing the person to dot name. So can you expect this to be person one name still John? Let me know your guesses. I will give you a second. I am going to sneeze again. Sorry. So, what are your guesses? I just see I can make here Alberto.js is back. Thank you. What are your guesses? Let's see. Let's run this. First call of person one, it's name Alberto. Age 30, greeting, blah blah blah, Alberto string, hello, I am Alberto and I am 30 years old. Second call give us the same. I am not lying, I can show you. This we can add person one and person two. And call this again, and you will see person one, it's now named Alberto, and person two, it's now named Alberto. And you may be thinking, why the hell that's happening? If I just rename the person two dot name, I didn't wanted this to be renamed Alberto for the person one, even though even that I do that before the execution. But what happened if we change it here? Before the just after the console log was called. Will that change? Again, think of it. You have 1 second. uh, person one, it's done, and person two, it's Alberto. That's happening now. But why that happened? Are we doing something wrong? If I call person one greeting here and I run this again, yeah, there's no person one, just person. It says two times, hello, I'm Alberto, and hello, I'm Alberto. So, is this part lying us? Are the name John no good anymore? Well, remember our mental model. Let's take a look line by line to what's happening. First, we declare this can be removed now. An object called person. That object we declare it with some properties by default. That its name is John, its age is 30, it has a greeting calling the name, it has and the age, and a property or a method that contains the who am I, right? But doesn't care or doesn't put too much attention here on the who am I. Then we call a person2 variable that is equal to the person1. This is the tricky part. What happened in your mental model here? How do you imagine having these? Let's go to Figma. So, you probably be thinking something like this. Person 1. And let's call this person 2. Inside this, we are going to say the object, right? The object containing name and the object containing the age. And remember what I told you about the mutable and immutable part of the universe. Primitive values are immutable. So if we were saying something like let person 1 being 10 and let b being a, let person 2 person person. I think I just uh, okay, don't worry. Um, let person 1 being 10, let person 2 being person 1. That would say person 1 points here and person 2 points here too, right? That's fine. For objects that are mutable, that's not the same and that's not completely true. Oh, I just received a message for Binja to catch up some minutes after our next stream, which is the um, today on Global Hack Week. So I think I need to rush to end this session in 10 minutes. Sorry for that, but don't worry. We'll still have part three and part four for this. Um, so I am going to end this about difference of mutable on the objects, and we're done for the session. Uh, uh, um, okay, yeah. But when an object exists, the thing that happens is this: person one, it's declared to be the object, right? And this object contains name equals 10 and age, sorry, name containing Alberto, and the age equals 24. I'm 24 years old. And what happens here is that person one points to this object, and inside this, (24) Alberto, right? And this line, this age here, is still a variable, but it's living inside the object. That's another planet. Remember, all planet has person two and person one, but this planet, this object planet that it's mutable, has age that points to 24 and name that points to Alberto. What happened when we assign let person two to person one? It's that this doesn't create a new planet. This doesn't create a very same one like this. Same as the previous example, they both point to the same planet, to the same object here. So if we say in the next line, person 2 dot name equals something else, not Albert. What happened is that then this, not Albert, right? This points no more to Albert. This point to not Albert. Give me a minute. Hey, sorry, I'm back. Um, yeah. So what happened is that person one was declared with this object. So this object popped in the JavaScript universe as this planet, and this object contains name and age. But when we said person two points to the same planet that person one, what's happening here is that these now are two binded. And when we set person2 dot name, we are accessing these of the same planet of person one. And when we change it, this happened. So in the next part, when we want to say person one dot name, this will be equal to not Alberto, right? This is what is happening. So let's return to our code. Um, in other languages terms, objects are a copy by reference, not copy by value, assigned to a reference of B, like a pointer. Yeah, thank you. You're getting it so right. So what's happening here is we're doing that declaration. They both point to the same object before we make this statement here. So what's happening here is that at this point in the history of the memory, we already changed the name to Alberto. That's why when we run it this way, this person it's no longer called John, but Alberto. If we don't do that here, but do it here, the problem is that we print this statement with the name John, but then we change the name to Alberto. The problem is that there are no different persons. Mind blowing, right? The problem is that we are just renaming that same person to Alberto. This can be tricky, and this can be a thing that you don't want to do. Also, a thing that you do want to do, right? So again, that's not that JavaScript is bad. That's not that JavaScript isn't cool. That's not that JavaScript doesn't understand what you, as programmer, want to do. The problem is that you, as programmer, don't understand what JavaScript is doing. If we, for instance, change this to be a new object of person, things change a lot. And let's try to do that. What's happening here? What I just did. I don't remember if that's the correct declaration. Let's do it copilot. Make person to an instance of person. Yeah, sorry. And now, what happened here, it doesn't matter we change person to name to Alberto and then call it person, because at this point, person one is still John. And even after all of this, if I call the person one greeting here, it's still John. And I can change person to name to person to dot age to 24, which I am. And we will see at the very end, Alberto is 24 and John is 38. And this is because we create an instance of the object. Return. No, I forgot to add this to stage. Give me a second. Oh, sorry. I hate StreamYard because when you start sharing a screen, it changes you to that screen, but it doesn't add it to the well. It doesn't add it to the stream. I'll do this very quickly again. What I had changed it's that here previously this person two was declared to be person, right? A pointer to the same object. That means the same planet. That's why when we changed these variables, it changed for both. But if we do a thing that's called creating an instance of an object, that means an object creates another planet, same as person. Well, now person 2, it's pointing to a completely different planet, but has still the same properties and the same method that the first object you wanted to create. Now we changed the name to Alberto, and now we changed the age to 24, and it doesn't matter if we change it here. We if we call person one object, this is John, because person one still the same. It doesn't is binding anymore to person two, and person two it's Alberto, and its age is 24, and the greeting message says, "Hey, I'm Alberto, and I'm 24 years old." The greeting message for John says, "Hey, I'm John, and I'm 30 years old," and that's it. That's the difference between mutable and immutable um, elements in JavaScript. That's the difference between arrow functions and regular functions. That's the differences between anonymous functions and the ones called with a proper name. That's the difference between primitive values and objects and functions. So let's just quickly go again to Figma to make this a better understanding. We have a duplicated thing about this, this. And to end, I want you to guess where this age is pointing based on our mental model, based on what I just said to you, where this age is going to be pointing. A new planet called 30? Well, that was a trick question because actually I said that this was a new planet, yeah, that was 30 because this is John. But before changing that, before changing the age to 30, these both were pointing to no, sorry, these both were pointing to 30 because this 30 it steals a primitive value, strings, numbers, booleans, undefined, null, symbol, and big numbers are immutable, and there's just one planet like them. These two are the same, right? Equally the same. It contains name and age values, but there's only one 30. There's only one Alberto string. There's only one not Alberto string, right? So then we change it to 24. So that's why these are different. And they might be and look and feel the same, but these are different objects because they are not primitive values. They are objects, they are immutable. And if we change the name pointer for person two to, you can say true. I mean, that doesn't make sense, but you can do it. It doesn't affect person one because it's an instance. And well, we can call it 10 of a string, right? And well, that's, oh my God, again, I forgot to share. Oh, Okay, here's the figma I was sharing. These might look the same. These are the two objects. These are the pointer name to Alberto and sorry to Alberto and to not Alberto, the age to 30 and the age to 24. These now person one and person two are different objects, even though they look, feel, and practically are the same, but there are different planets in the JavaScript universe. So when we change the name to 10 or to true or to something else in the universe, it doesn't affect person one, right? So that's it. Yeah, sorry. um, yeah, sorry for my screen not being visible. Okay, and I'm running out of time because I need to prepare for today on Global Hack Week. To do a recap of what we saw in this session, we saw objects and functions. Just objects and functions. I mean, that it was a really complicated things. We remember what primitive values were. We mentioned the type of to check the type definitions in JavaScript. We checked objects, how to say it, properties, methods, which are the functions inside objects. We checked functions. We checked hosting. We checked the difference between bar, let, and const. We check the difference between an arrow function and a regular function. And well, that's a lot of information. And still, we have a lot to see about JavaScript. Next, on part three, we are going to check the expressions and statements, the operators, the control flow, and the loops. So I want to grab in part four for the event loop and yeah, and that's all. That will be a very interesting session. So again, if you missed part one, you can always watch the recording here on the YouTube Majorly Hacking streams. If you are just driving to this session, you can watch the recording too. Or if you want to check it again, because I know there's a lot of information, a lot of things to cover. Well, here there will be the recording always. So thank you a lot for joining me. And well, I see you in a couple of seconds, a couple of minutes for the Today in Global Hack Week. And then the night, well, my night, I don't know what time will be for you, for the part three of this series of the JavaScript universe. Thank you, Alberto. See you today at Global Hack Week. So thanks. Bye bye.